Good morning, class 12. I'm Sana Uzma from the Millennium School. In today's session, students, I'm going to begin with the new unit of physical chemistry, that is chemical kinetics. Before I begin with this chapter, children, let me tell you something about this chapter, that if you compare this chapter with the rest of the two chapters that we have finished till now, that is electrochemistry and solutions, you'll find it more interesting and you'll find it more easy. But only when you are going to follow the videos from day one, you are following the instruction given by the teacher from day one. So with this hope, I am going to begin with the chapter chemical kinetics. And today is the introductory session. So first of all, let me introduce you with the chapter. What all are the important topics that we are going to cover up in this chapter, and what is the base, what is the foundation of this chapter, what is this chapter about. Actually, this chapter will be dealing with the rate of the reaction throughout and the factors affecting the rate of the reaction. So this is the basic thing that we are going to deal with in this chapter, chemical kinetics. Kinetics means anything which is in motion. So we will be dealing with the reactions and rate of the reactions, that is the rate of the reaction during the course of the reaction, that is when it is taking place, when it is occurring. So here is the definition. As you can see, it is the branch of chemistry that deals with the rate of reaction, the factors affecting the rate of the reaction, and the reaction mechanism, where we will be paying more emphasis on the first two things, that is rate of the reaction and the factors affecting the rate of the reaction. So when we say rate, the first thing that comes in our mind is something which is changing with respect to time. So yes, when we are talking about the rate of the chemical reaction, obviously we will be able to find out the rate of a chemical reaction only with the help of the change in concentration of reactant or product with respect to time. So here you can relate it with the speed of a moving car, speed of any moving vehicle. If you have to calculate the speed of any moving vehicle, what formula do you apply? We apply the formula as the distance covered upon time taken. Similarly, when we are talking about the rate of the reaction of any chemical reaction, we are going to find out the change in concentration of the reactant or product with respect to time, or you can say change in concentration of reactant or product upon time. This is what the rate of reaction is. So in today's session, we will be studying about rate of reaction only. And children, please pay attention to these topics, to this chapter from the very beginning of the session. It's a request. Don't miss out any of the topic, because this is very scoring, and I have observed that maximum children, they do the questions related to this chapter correctly. So don't let this chapter go like this. And all those who were not paying attention in the previous days, or all those who were not very much attentive during the last chapter or last two chapters, children, it's not too late. Even if you wake up now and start paying attention now, I'm telling you, the ways will be easy for you. Otherwise, you are going to suffer at the end. So let us see that what are the types of reaction. The types of reaction that we commonly observe are categorized into three types. That is, the reaction can be very fast, the reaction can be very slow, or the reaction can be a moderate, neither very fast nor very slow. So very fast reactions are usually ionic reaction. Like an example is mentioned here. An aqueous solution of sodium chloride when mixed with an aqueous solution of AgNO3. This is in the form of aqueous solution, and this is also in the form of aqueous solution, and the product that you get, this is the PPT, and this is also again in the form of aqueous solution. So these ionic equations are actually very fast equation. The moment you dissolve NaCl in water or AgNO3 in water, as you prepare the aqueous solution, what happens? They dissociate into ions, and when so it becomes very easy for these ionic reactants to interchange their position and form new products. So these reactions occur in microseconds, you can say. So since the speed is too high, so it is not possible for us to find out the rate of reaction for such reactions, that is the reactions which are occurring at a very quick rate. Then comes very slow reaction. The example of very slow reaction, a very common example, is rusting. Rusting is a process that you people are well aware of. It occurs on the surface of iron, but this process takes months or years to complete. So again, there is no point calculating the rate of reaction of such slow reactions. So this is also, rate of reaction cannot be predicted for such reactions also. Now coming to moderate reactions. Moderate reactions are generally molecular reactions. As I told you that the very fast reactions are ionic. Ionic means the reactant are in ionic form, ionic compounds, and the product are also ionic compound. Here you can say these are covalent compounds, where there will be involvement of breaking of bonds and formation of new bonds. Such reactions occur in finite time. That means the time can be calculated. The rate can be calculated for such reactions, for molecular reactions. So molecular reactions are they occur at moderate rate. An example is mentioned here, Haber's process, though it is reversible, but I have not substituted here reversible sign. I have just mentioned this reaction in one direction, that is in forward direction. And as you know that in case of nitrogen the bonding is like this, in case of hydrogen the bonding is like this, and in case of ammonia the bonding is like this. So what happens in this case, there is rearrangement of bonds. As a result we get a new product, and the reaction occurs in a definite interval of time. So it is very easily feasible for us to predict the rate of reaction of such reactions. Now moving on to the types of reaction rates. The reaction rates are basically two types, average rate and instantaneous rate. So what is the basic difference between these two? Average rate means the rate which is measured in appreciable time interval. That is, you have a certain duration where you have to find out the speed or the rate. Like a train moving from Lucknow to Delhi. For that, you have to find out the average rate of the journey. And if I say that find out the speed of that train at any particular instant, at any particular time, then you are calculating the instantaneous speed. So I hope the meaning of the two is clear. Average rate is measured for appreciable time interval, whereas instantaneous rate is measured at any particular instant. Now moving ahead, here is the method of calculating the average rate of reaction. How do we find out the average rate of reaction? To explain it, children, I have a reaction in front of me. You can see here 2A plus 3B gives 4C. Now when you have to find out average rate of reaction, how do we find it out? Delta A upon delta T. Delta A means change in concentration of A upon change in time, which is equal to change in concentration of B upon change in time, which is equal to change in concentration of C upon change in time, because the concentration will change at the same time. As the concentration of A and B will go on decreasing, the concentration of C will go on increasing. Now what happens when you are calculating the rate? This stoichiometric coefficient is written here in the form of denominator, as you can see here. This 2 has come down, so I have written 1 by 2. This 3 has come down, so I have written 1 by 3. And this 4 has also been substituted here in denominator. So stoichiometric coefficients are written in this way. And why have I substituted negative sign here? Because children, rate can never be negative. when we are talking about the chemical reaction, rate can never be negative. And as you know that the concentration of A will go on decreasing with the course of reaction, because the reaction is moving in forward direction. So obviously these two components will go on decreasing and this will go on increasing. So this concentration will be negative because it is decreasing. So as to keep the rate of reaction positive, we mention negative sign here, because negative and negative will be positive. Similarly, in case of B, the concentration of B will be decreasing with the passage of time. So to make it positive, this minus sign will be substituted here. So you can remember it as, with reactants we need to put minus sign, and with products we never put minus sign because it is already increasing, which is positive. So please remember, rate of reaction can never be negative. So to keep it positive, we substitute these signs here. Now let us take another example. As you can see here, I'll suggest that pause the video for some time and try to solve this reaction on your own. For this also, you need to find out the average rate of reaction with respect to the two reactants and the product. It is mentioned here. With respect to X, it will be minus 1 by 3 delta X upon delta T. With respect to Y, it will be delta Y upon delta T. With respect to Z, it will be half delta Z upon delta T. So I hope the method of expression is clear to you. Now here comes very important question which you get in your exam pertaining to the reactions. You have to find out the rate of appearance of Z. Why have I written appearance? Because with the passage of time, Z will appear, whereas X and Y will disappear, because these are the reactants and this is the product. So rate of appearance of Z will be written as delta Z upon delta T. Now point to note here is this: we will not substitute the stoichiometric coefficient here or the negative sign here. Or for this though you don't need, because obviously it is the product. And rate of disappearance of X will be written as it is only delta X upon delta T without any stoichiometric coefficient. So please do remember this, children. I hope average rate calculation is clear to you. Now moving on to the instantaneous rate of reaction. Now the difference between the two is very small. The method of expression is same. Like if I have taken an example here, A is getting converted into B. How will you write the average rate of reaction? It will be equal to delta A upon delta T with negative sign here, since there is no balancing mole or stoichiometric coefficient, so no denominator here. And delta B will be, with respect to B, it will be delta B upon delta T. This is average rate of reaction. Now what happens when we find out instantaneous rate of reaction? Instantaneous rate of reaction means the time limit, the change in time is almost equal to 0, because the time limit is very small. When you are calculating anything at any instant, the time becomes very small at that particular instant. So, and when you have to calculate something very small, we differentiate the equation. We use differential equation. So in place of delta, which is indicating the final minus initial wala change, we will replace this delta sign with D, and D indicates we are calculating it for that particular instant, which can be calculated with the differential equation. Rest of the things remains the same. So in place of delta, D is mentioned here, and I hope from physics you must be knowing it. You must have done differentiation and integration in physics in detail, though in chemistry it is not needed much. You only need to remember it here as that since we are talking about instantaneous rate, which is calculated for the time limit being 0, so delta will be replaced with D. We will be using differential equation here. Rest everything remains the same. Minus sign will be used with reactant, and with product, there will be no minus sign. It will remain positive. Okay. So when average rate is calculated at any particular instant, or when the time limit tends to 0, then it is known as instantaneous rate. So I hope the two rates are clear. The method remains the same. I will be discussing questions based on this. Now moving on to the unit of rate of reaction. Since rate of reaction is equal to change in concentration upon change in time, And as you know that concentration, the unit of concentration is moles per liter. So I have mentioned here the unit of concentration, that is moles per liter, and unit of time can be minute, second, hour, whatever it is. So I've just simply substituted the units in formula and you'll get the unit as moles per liter per unit time, and time will be substituted accordingly. If it is given hours in question, then you'll write hour. If it is given second, then you'll write second. That depends. So I hope today's session is clear to you. So let's have a quick recap of what we did in today's session. In today's session, we had an introduction of the chapter Chemical Kinetics, where I told you that Chemical Kinetics chapter, that is the third unit of your book 1, is all about the rate of reaction, the factors affecting the rate of reaction, and children, it is very interesting and easy chapter. So please pay attention from the very beginning. Don't miss out any of the video, any of the session. It's a sincere request. Okay, and then we discussed about the types of reaction, which include very fast, slow, and moderate. I explained you these types with the help of examples. So very fast are basically ionic equations because these occurs immediately, and very slow, the example can be rusting. It takes years for an iron to get rusted. So obviously there is no point calculating the rate of reaction for such reactions. Now coming on to the moderate type, for which the calculation of rate is applicable. And moderate reactions, the examples are molecular reactions, where we deal with covalent bonds, covalent compounds. And the types of reaction rates include average rate and instantaneous rate. Average rate means any process which occurs, which takes place in appreciable time interval, and any process that, or when you calculate the rate or the speed at any particular instant of time, that is known as instantaneous rate. Then here comes the calculation of average rate of reaction and instant rate of reaction. I hope the difference between the two is clear. Average, just the difference between the two is this. In case of average, we use this delta sign, that is final minus initial, and for instantaneous, we replace this delta sign with this differential sign. Rest everything remains the same. I explained you the types with the help of some hypothetical equations which you can practice, and you can take up some questions from your NCERT book also to make the concept clear. And then another important topic that we took up today is unit of rate of reaction. At times you get a question as simple as this, that is to find out the unit of the rate of reaction. So the formula is mentioned here and the unit is also mentioned here. So I hope today's session is clear to you. Now please start from the very beginning. Start compiling your notes and sending your doubts to the teacher. Thank you and have a nice day.